Okay, so now we're going to do a video on multiplying expressions with exponents. So let's begin. What's the easiest way to write 3 times 3 times 3? And if we think about it, that really is 3 to the third power. We know it's 27, but 3 cubed is even probably easier way to write it. If we do 5, we got 5 times 5 times 5, and that's 5 to the fourth. So similarly, if I do the 7 to the fourth, that means 4 sevens, and then 3 sevens all multiplied together. Well, if I count 1, 2, 3, 4, 5, 6, 7, that's 7 to the 7th power. And the same thing for the 5s. I've got 3 here. I write down 3, and I multiply it by 5 more, multiply together, and I get 1, 2, 3, 4, 5, 6, 7 5s, 5 to the 7th power. So there's a rule we need to learn, or I don't even need to learn it because every time you can just work it out. But it might be helpful to know that if the base is the same, that was if the number is the same on the bottom, the base, just add the exponents. So if you have some number like a times itself, but one's to the m power and one's to the n power, just add them together. As long as m and n are integers, okay? You don't want to. It can't be fractions, just integers right now. All right. So let's look at the next one. Let's practice a little bit. So for example, we want to rewrite this using the base once. We have 8 to the fourth times 8. Well, let's use our little rule. That's really 8 to the first power. So the base is the same. We're multiplying. So that's 8 to the what's 4 plus 1? 5. And you can always make sure about that or know that, because if I just write it out, 8 times 8 times 8 times 8, that means 8 to the fourth, times, because I'm timesing, 8 to the first power, well, that's just 5 eighths. So it's 8 to the fifth. Okay, this again, you want to always check to make sure it's the same base and make sure that you're multiplying. Once you know those things are going on, then you can add the exponents. So I know it's the same base, so I write the base down. I do 4 plus 5, and that's 9. So that's 11 to the 9th power. Here I have the same base. I'm multiplying, so we can add the exponents. What's 3 plus 2? 5, and then 5 minus 1 is 4. Okay, now the way we can think about that is, if we go over here, you can see, well, that's 2 cubed plus times 2 to the second power. That's 2 to the fifth. But remember, when anything's a negative exponent, it's really on the bottom, right? So we put it on the 1, 2 on the bottom because it's 2 to the first power. So if we do it, we can go 2 times 2 times 2 times 2 times 2, 5 2s with 2 on the bottom, and I can cancel, right? I can reduce it. So now I have 2 to how many? 2 to how many? 2 to the fourth. So that's another way to kind of show it in case you forget the rule or anything like that. Okay, here I have the same base. They're multiplying. The exponents are integers. Now what's negative 4 plus 4? Well, 5 to the negative 4 plus 4. Negative 4 plus 4 is 0. 5 to the 0. And we know 5 to the 0 equals 1. Okay? This one now, number 5, is x to the first power, really. If you need to write that in, go ahead and write it in. So I have my base. Same base, I'm multiplying. Exponents are all integers, so 1 plus 2 plus 3 is x to the 6th. Okay, now I have a little trick question for you. Can you do 2 cubed plus 2 to the 5th? Does that equal 2 to the 8th? And we have to say what? We have to say no. Why? Because we're not multiplying, we're adding here. So we have to really go ahead. That's going to equal 8, that's going to equal 32, and that's going to be 40, not 2 to the 8th. Okay, we'll talk about that some more too. All right, next one. All right, now we're going to simplify. Now we have some coefficients. We got some more numbers, but they're not exponents. So we can work this out and just do it. Just think about your rules and think about what you're doing and try to go just step by step. So first thing, this is just 2 times that n times 7 times this other n. Okay? Well, I know how to do 2 times 7. That's 14. So you have 14, and then that n and that n are the same base. I'm multiplying, so what do I do to my exponents? 5 plus a negative 2. So 5 plus a negative 2, or 5 minus 2 is 3. Here we go here. We have 5 times, they're all being multiplied. I got my 5, but it's just an x, it's a coefficient, so it's no other coefficient to multiply by except 1, which would make it 5. Then I have a. Remember now, this a really has a first, so 1 plus 5 is 6. 5 times a, make that a a little bit, make sure it's on the ground with the same as the 5. 5 times a to the 6th. Okay, here I'm multiplying, same base. Now I've got one coefficient, that's just negative 7. Sometimes you'll see them put parentheses around that, just to let you know that negative goes with that 7. So I just have negative 7 as my coefficient. I've got my n. I've got 2 plus 3 is 5, plus I have that 1, that'd be 6. All right, here, got a lot of things going on. I got 3 coefficients, and they're all being multiplied. So it's 6 times 3 is 18. 18 times 2 is 36. Or you could go 3 times 2 is 6, and 6 times 6 is 36. I've got my base, which is y. Now remember, don't multiply the exponents. You're going to be so used to multiplying because you just multiplied the coefficients that you want to make sure, oh no, the exponents I have to add. So it's 2 plus 3 is 5, and then 5 minus 4 is 1. So you could just leave it like this, or you could put the 1 there. But the simplest way to write it would be just without the exponent there. Okay, this one. Here I have 2 different bases now, so be careful. My c I can write down because I got 2 of them, and I got 4 plus 7. That's c to the 11th. But the d is just negative 3. Now sometimes they'll have you write it and they'll say simplify with no negative exponents. So remember, the negative exponent goes on the bottom, or it's the inverse of it, the reciprocal of it. So here you would really say c to the 11th over d cubed if they had those directions. Here I didn't write those directions, but if you had them, that would be what you would write. Okay, for number 6, I'm going to have to write it in here. I got 5 times 2 times 3. So 5 times 2 is 10, times 3 is 30. Okay, then I have an m, I have an 8 here, and I have a 1 here, so that's m to the 9th, and then the p to the 4th just stays right there. Next one, now here they have parentheses, but all those parentheses mean is we're just still multiplying everything together. So it's 2, you don't really need them there. You can go ahead and just put maybe a dot here if you need to, but otherwise you really don't need them. So 2 times 4 is 8. And remember, don't add those, you're going to be multiplying, and then you add the exponents of the bases that are the same. So here I have 2, here I have 1, so it's x cubed. Here I have y cubed, plus, in other words, 3 plus a negative 2, or 3 minus 2 is 1, or I just leave it like it is to make it simpler. Last one on this one. Okay, I got 2 times 7 times 2, so really 7 times 4 is 28. I've got y third to the 4th, so 3 plus 4 is 7, and then I have x squared. So that's the simplest way to write that. Okay, so it gets kind of simple after once you know and can work with all the things, it gets a little simple. All right, next one. Sometimes now you're going to put some geometry into it. And it says find the area. Remember how to find the area is the length times the base, or the side times side. Here I have a square, so the area is going to be the side squared. So in other words, it's going to be 3x to the 4th times 3x to the 4th. So 3 times 3 is 9. X to the 4th times x to the 4th is x to the 8th. Not 16th. Remember, you got to add them. Okay, now here you have a triangle. Remember, the area of a triangle is 1/2 the base of the triangle times the height of the triangle. So I have 1/2 times the base. The base is 6x squared, and the height is 9x cubed. Okay, so I have to multiply my coefficients. Half of 6 is 3, and 3 times 9 is 27. So it's 27 and x to the 5th, because 2 plus 3 is 5. Don't multiply the exponents. Be careful. Okay? Next, we're going to have a couple of different kind of problems that you might run into. Make you think. Show 2 to the 20th power in 3 different ways. And so I did 2 of them. Okay, why would this work? Because again, same base, I'm multiplying, so you add the exponents. So that's equals 2 to the 20th. Okay? This is, again, same base, multiplying, and 4 plus 6 is 10, 5 plus 5 is 10, 10 plus 10 is 20. So I want you to go ahead and think of another way to do it, okay, and see if you can come up with. You can go 2 to the 30 times 2 to the negative 10. That'd be a way to put in negative 1, that'd be 2 to the 20th. Whatever you put in, you can show me in class. All right, this one does this is multiplying. Okay, so here it does 8x to the 8th times x to the squared equal x to the 5th plus x to the 5th. Well, if you're really sharp, you'll be able to see no, because this is a times and this is a plus, so no, it does not, because this equals x to the 10th, and this equals, well, guess what? These are like terms. It's the same base raised to the same power, and I have 2 of them, so that's 2x to the 5th. So there you can say that no, they're not the same. So be careful. Remember all the things you've learned so far this year. Okay, last page, last board. Okay, Mark thinks x to the 4th plus x to the 4th is 2x to the 4th. Ryan thinks that x to the 4th plus x to the 4th is x to the 8th. Kind of what we just did. A little bit of a different kind of problem. Who's correct? Well, who did we just learn about just now? Mark. Mark is right, because they are like terms, and we added them together. So 1 plus 1 is 2, 2x to the 4th. And this is going to be, he's thinking of being multiplied, but they're not being multiplied, they're being added. Okay, so here's something with negatives that we have to talk about a little bit. Does the negative 2, the whole negative 2 cubed, is that the same thing as the opposite of 2 cubed? Well, let's see. Negative 2 cubed means negative 2 times negative 2 times negative 2. Well, negative 2 times negative 2 is 4, and 4 times a negative 2, I'll put it right here, is a negative 8. Well, let's see, does that equal the opposite of 2 cubed? Well, 2 cubed is 2 times 2 times 2. So 2 times 2 is 4, 4 times 2 is 8. So does negative 8 equal the opposite of 8? In this case, it does. Okay? Now we'll do another one. Does the opposite of negative 2 cubed equal 2 cubed? Let's see. This is the opposite of what we just did up here, because that's the same